In this tutorial, we'll look at Fibonacci transition as a function, as well as Fibonacci transitions as a function, as well as the remixing function. So let's look at Fibonacci transition and Fibonacci transitions. These return a list in which one repeating element is gradually transitioned to a second element, and the repetitions and the replacements are determined by a Fibonacci series. The Fibonacci series, as most of you will know, is an arithmetic series in which each element is the sum of the previous two elements. So if you start with 0 and 1, the next element will be 1, because 0 and 1 added together is 1. Then 1 and 1 is 2, 1 and 2 is 3, 3 and 2 is 5, 5 and 3 is 8, etc., etc. So if we just look at the first function, Fibonacci transition in singular, we transition here only between two items. The function can be called with 1 or 3 arguments. If one argument, we transition from 0 to 1 in a list length of n. That's the first argument. So if we call Fibonacci transition with the argument 50, we get a list of 50 numbers, all of which are zeros and ones, but we transition gradually from 0 to 1 over the course of the 50 elements. So you can see here, if we count the number of zeros, 0 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The 13th element is a 1. Then we have 1, 2, 3, 4, 5, 6, 7 zeros, and then the 8th element is a 1. These are Fibonacci numbers, of course. We get towards the middle, and they alternate then more between zeros and ones, until then the number of ones increases until that then dominates. If we call Fibonacci transition with 3 arguments, the second and third arguments are the elements that are transitioned across. So we now no longer move between 0 and 1, but between element S in this example to element E in the example. In this example, we can see how we use the Fibonacci transition function to make a piece that's minimalist, something a little bit like Steve Reich's electric counterpoint or his music for 18 musicians. We make a Fibonacci transition from the number 1 to the number 2, and this will be used then to select the sets and the rhythm sequences used in the piece. So we'll get a predominance of the repetition of sequence 1 and set 1 at the beginning, moving gradually towards set 2 and rhythm sequence 2 as we go along. This example also shows us a little bit of Lisp trickery in that we can splice in the results of a call to Fibonacci transition as a list, as if we would hand-typed everything. So usually we would type in, for the set map, there would be a quote, and then the section number, and then the actual numbers or symbols for the sets. Whereas here we have a back quote instead of a normal quote, and a comma just before the variable name, so that we splice in this list which was created by the call to Fibonacci transition above. Fibonacci transitions through multiple items. This applies a simple Fibonacci transition between two consecutive items, but calls it one after the other to go through many items, as many as you wish within reason. So this can be called with 2 integers or 1 integer and a list. If we call the function with 2 integers, then the first integer is the length of the resulting list, and the second integer is the number of consecutive numbers from 0 that will be the items returned. So for instance, if we call Fibonacci transitions with the arguments 76 and 4, we get a gradual transition at first from 0 to 1, but then as that dominates, we then start splicing in 2 until it dominates, and then we start splicing in 3, and by the end of our result list, 3 is the one that's dominating. If we don't want to use the numbers 0 to n, we can of course pass a list, and then these will be the items through which the algorithm transitions. So for instance, if we call Fibonacci transitions with the arguments 304 and then a list consisting of S, E, Q, and H, we slowly transition from S to E, then E to Q, and then Q to H by the end. In our next example, we see a use of the Fibonacci-transitions function to extend our previous example, which was imitating something like Steve Reich's Music for 18 Musicians, but instead of now making a simple transition from one set to a second set, we're now going to transition over 4 sets through the whole piece. And this applies also to the rhythm sequences also. And you can see if we look at the rhythm sequence map here, we're using our backquote and comma notation to splice in our call to the Fibonacci transitions function. But the rhythm sequences that are being used by each of the instruments in the ensemble are different. The flute will transition from 1 to 2 to 3. The oboe will transition from 2 to 3 to 4, and the clarinet from 3 to 4 to 5. And all of that over this variable num-seq, which we define at the very top of the let. That's used throughout that mini call. Remix in creates a new list by lengthening an existing list. In fact, it inserts consecutive elements of the original list back into itself. So it's mixing in earlier items of the list back into the original after it's seen the third unique item. So this can be quite useful in creating musical structures where references to earlier items, perhaps earlier sets or earlier rhythm sequences, would be useful in our musical structure. So items are mixed back in sequentially starting at the beginning of the original list, and the insert points are determined by Fibonacci series. So for instance, if we call remix in with this list here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, you can see that by the time we get to 1, 2, 3, 4, 5, we then splice in the first element of the list, 1. Then we proceed to 6 and 7, and then we get a 2, 8, 9, then the 3, 10, 4, 11, and 5. We can use the remix in algorithm in another piece, which is again similar to our previous examples in that it's basically minimal, but we're now going to mix in earlier elements of the list. So we can see in the let example here, we've got remix series as a variable, and we call the function remix in using as its list argument the result of a call to the Fibonacci transitions. And this is going to transition over the numbers 1, 2, 3, and 4. Now that remix series is then used in the set map, and you can see again our backquote and comma notation for the set map. The first section, 1, will simply take the value remix series. So now we're very clearly moving into the area of algorithmic composition. We're not any longer taking a declarative approach to Slippery Chicken, but really an algorithmic approach. Our order of our sets is actually determined by our Fibonacci transition combined with a remix in algorithm.